All right, let's take a look at the humerus. So with the humerus, the first thing you'll notice is that there's a real nice ball-looking area right here. Nice and shiny, right? In reality, it will be covered with cartilage, so it should be even more shiny, should be even more slippery than what we see here. Now, some of you guys eat chicken, and we'll use that analogy a lot. So what I want you to imagine is when you're eating a drumstick. As you're eating the drumstick, number one, the drumstick is the tibia of the chicken, right? So as you're eating the meat from the drumstick, I know we're gonna actually talk about the meat too later on, but as we're eating it, you'll notice that the ends of the drumstick, both the top and the bottom end, that if you eat it and you take some of the tendons off, you'll see some real shiny regions. Those are the cartilage that are found at the ends. We call them articular cartilage. We have the same things, right? Now, most people don't really take the time to look at, the drumstick is easy to tell, but when you're looking and eating, let's say, right, a chicken wing, right? If you eat the chicken wing, you have an arm region that's very short. It is an arm, it is a humerus, right? And if you look real closely, the end of it is very shiny as well. It is going to end in something very similar to what we see here, right? This area right here is called the head of the humerus. The shiny head of the humerus right here. Excuse me. The shiny head of the humerus goes into the glenoid cavity. Since the glenoid cavity is very shallow and the head is very smooth, it allows for great frictionless movement, right? In some people, the movement is so fast that you can throw a football, baseball, 70, 80, 90 miles per hour. Yes?
Can it possibly pinch the top of the...
It can't, right? You're talking about right here, can it make contact to that top of the chromium? It can't, depending on the movement that we have, right? But usually, right, that's why nowadays physical therapists will tell you to not do certain kind of movements for weightlifting that when I was younger, right, you almost had to do, right? So we'll talk about those coming up. You can have impingement of both nerves that exit and muscles that are there. So that can happen. Head of the humerus, nice, shiny, smooth. And as we go forward right here, right, how can we tell which is a front and which is a back? Right, couple things. One way we can tell is by looking at the bottom. If you see this big old depression, this was the back. Right? Another thing, right? When we look at the back, it's missing something we call the lesser tubercle. That's it. Do you see that? This is the lesser tubercle sticking out to the front right here. It's only found in the anterior part of your humerus. Obviously, if you have something this big and this very, large that's sticking out, you're gonna have some very strong muscles that attach here. Part of your rotator cuff muscle and part of your pec major muscle will insert right here at the, lesser tubercle. Now the greater tubercle is found lateral to it. And it's this kind of big old area that kind of moves outwards right here, right? Notice that it's not just a ball and then it goes flat, right? You have a piece of bone that sticks up right here. That piece of bone that sticks up is called the greater tubercle. You'll also have, you're gonna see, there's 4 rotator cuff muscles. A lot of them insert at the greater tubercle, right? So there's a reason why these tubercles are so big, tough, and if you feel it, rough, right? The roughness represents your actual tendons inserting into this region. So that roughness, again, there's a reason why it's rough. As we go downwards right here, the long part of any long bone is called the shaft. But notice, the shaft isn't just straight and smooth. On the outside right here, you feel an area that's rough right here. Right? Now, I'm gonna bring in some real bones next week, and with the real bones, right, I want you to actually feel how rough it is on a real bone. Reason why? Well, here they can kind of approximate it, but in real bone, it's somebody's arm, right? So throughout many years of use, you're gonna have something a little bit larger, or some people, a little bit smaller area for this roughened region where the deltoid muscle inserts. This area that's rough and it's on the side and it's found like halfway through the shaft, this is called the deltoid tuberosity, right? Tuberosity, tubercle, trochanter, all represent rough or extensions of the bone where muscles are going to insert. As we move downwards right here, now we're going to look at the distal end of our humerus. Some of this we can feel, right? So what I want you to do is bend your elbow and directly, right, lateral to where your elbow area is, you should feel two pieces of bone. One on the medial side, right here, one on the lateral side. Those are called your epicondyles, right? That is these areas you're feeling. Notice the median one is a little bit easier to touch and feel, right? Why? Well, the median one right here sticks out a little bit more. See that? Now with these epicondyles, again, it's rough, right? These epicondyles, especially the medial ones, allow all of the muscles of your forearm, the flexor muscle, right? So muscles in the front of your arm, whether it's a front upper half, front forearm, all those muscles allow us to flex, right? Flexion is movement of a joint less than 180 degrees. Again, anatomical positioning, all right? At anatomical position, my arms are fully extended. My joints in my arms are fully extended, right? So when I move it less than 180 degrees, I call that movement flexion, right? That's true of my forearm. At anatomical position, it's fully extended. So when I move that joint less than 180, close to 90, we call that flexion. So flexing is different than contracting, right? Contracting means you're contracting the muscle. It can cause flexion or it can cause extension depending on the muscle I am contracting. So all the muscles in your forearms, when you contract it, flex. All those muscles in the forearms, right, that allows you to flex your forearms. Even the ones that are in, that allows you to move your fingertips. And you can see them wriggling around when you move them. All those muscles there, they originate at this medial epicondyle. That's why it's so big and tough and rough, right? On the other side, you have the, right, lateral epicondyle. The lateral epicondyle, I want you to flip your hands over. The lateral epicondyle is where your muscles that allow you to extend meet, right? So what I want you to do is just put a couple fingers on your lateral epicondyle. Turn your arm around, and I want you to just move your fingers up. You should feel some muscles kind of work. They should be contracting, and you should feel it very close to that lateral epicondyle, right? The reason why? All the flexors originate on the medial side. All the extensors originate on the lateral side. So these are your lateral epicondyle right here. Now, the next two regions are going to allow for movement of your forearm, right? So right here, here's your ulna. Your ulna looks like it has a C-shaped region. So right away, it should be easy to tell which one's the ulna, which one's the radius. The ulna has this big old area right here called the ulnar cranium, which we'll talk about more in a second. The radius doesn't, right? And so it sits like this. Your elbow joint should look like this, right? With your elbow joint, it's incredibly stable. This is one of those weird joints in our body where it's actually 3 different bones. Now you figure, oh, isn't our knee like that? No. Our knee is actually only 2 bones, between your femur and your tibia. We have a fibula, but it's not part of our knee joint. So this is one of the rare joints where it's actually 3 separate bones forming our elbow joint, making it a lot more complex, all right? So when we put these together, what do we get? you get this area right here that looks like a little bell. This area right here that looks like a little bell makes contact with the ulna. This is called, right? So you have the trochlea right here, or the trochlear process. The trochlear process, or trochlea, over here, that allows you to make contact and form the joint with the ulna. Your ulnar joint is incredibly stable. It only allows you to flex and extend. That's it. Right? So here's the ulna kind of making contact with the trochlea. Right? Now, there's a big notch right here. So when you bend it, that part of the ulna goes into that opening. This is called the coronoid fossa, right here. So here's a coronoid fossa. It's just a little depression immediately superior to the trochlea. So here's a trochlea. Here's the coronoid fossa. Why is it called a coronoid fossa? Because this part of the ulna is called the coronoid process. Right? So the fossa matches what goes in it. So the coronoid process of the ulna, eventually when you bend it completely, that process goes right into that fossa. It's named after the bone that goes into that fossa. Right? This is a coronoid fossa, immediately superior to the trochlea. Now, the other joint is between the humerus and the radius. Now, what happens with this joint? This is a joint that's more movable, right? So take a look. The head of the radius right here is nice and flat. The joint it's making contact with is nice and smooth and round right here, right? Because of that, there's no catch, right? You can spin the radius back and forth like this without damaging the radius and damaging the joint. This is a joint that allows us to pronate and supinate, in other words, right? That's the spinning that we're talking about, right? When we spin and supinate and pronate, that's what's happening in the joint itself. All right, this nice round area is called the capitulum. And the capitulum makes contact with the rounded head of the ulna. Now, the last thing we see here, again, capitulum, trochlea, coronoid fossa, medial epicondyle. How do we know it's medial? If you're ever confused, the head always faces medial, right? It's part of the joint. It can't face outwards. If it does, you have an issue, right? So the head always is medial in every bone. So if it's on the same side as the head, it's medial. The other one then is lateral epicondyle. The last thing we see here in the bottom is this big old indentation. This is called the olecranon fossa, right? The olecranon fossa, we can feel. So I want you to bend your elbow again and feel on top right here. As you feel on top right there, right, you should feel a little depression. But what I want you to do is slowly extend your arm. And you should feel a piece of bone going into that area. What are we feeling? As we're bending our arm right here, you're able to kind of feel this, right, olecranon fossa. As we extend, the olecranon process goes into that fossa. And that piece of bone that you're actually feeling that goes in there, that's actually part of your ulna that goes in there. All right, let's take a little break.